At hand.
The task at hand was to create a wind tunnel based on Inholland tasking Inholland Composites to actually complete the wind tunnel in their basement. I've done my third year internship at Inholland Composites, and so it was my job to actually complete the wind tunnel. When I started this internship, most of the wind tunnel was completely finished in the design work. This is with a program called CATIA. I designed multiple parts of the wind tunnel, but my main task was to design the test section with its respective frame and the frame that will implement the pitot tube. So the main tool that we actually used was the laser cutter, because this was anything that needed to be done, even if it was a tool, a marking tool, a hammer tool. Everything can be just sent to the laser cutter and it'll cut it out. The workshop was also used. This is mainly because there's a welding bay in the workshop, a sanding bed and a horizontal saw. And that was mainly used for the construction of the frame, the frame that houses the actual test section, and the support frame that it rests on. So. Alright, so we're in the center part of the wind tunnel now. This is the fan, so this is where the flow will originate from. The fan will push the air into the round square part. This is the last piece, the last composites part that we actually have in the wind tunnel. It will further go into the third diffuser, and the corner section will redirect the flow with the vanes, because there's vanes that are implemented. The flow will be redirected again 90 degrees in the final corner into the settling chamber, and once that's done, it'll be accelerated in the contraction chamber. The contraction chamber is just on the edge of this test section, and from there it will be pushed into the first diffuser and circulated back around through the first corner and the second corner, essentially creating a square. Alright, so this is the front face of the wind tunnel. This is the final corner section, the fourth corner section. The flow will be arriving in this direction and will be redirected 90 degrees into the settling chamber. That's done by the 20 carbon fiber vanes inside that will redirect the flow. The settling chamber is the most important part of the wind tunnel, because this is where the flow will actually be corrected, so it will be more laminar, straight. And at the moment the wind tunnel is in its optimization phase, so we have to actually experiment with the flow correctors, meaning the honeycomb and the tension screens, to actually get the best flow in the test section. So at the moment we've chosen to go with one screen of honeycomb and 3 tension screens. From there, the flow will actually be accelerated, because you're going from a larger area into a smaller area in this contraction chamber. That will be accelerated into the test section, and by then, ideally what we need is just laminar flow in the full test section. The only way for us to know this is to use the pitot tube, and the pitot tube has an axis system that will measure the full cross-section of the test section. So once laminar flow is achieved in the current test section, the idea is to make multiple test sections that can house models. From these models, students can measure the pressure distribution or drag coefficients of their models. An example of a model is this is an airfoil profile, and has static pressure tubes that can give us an idea of the pressure distribution across the airfoil. So these are the sort of things that the wind tunnel can provide. They're sort of experiments.